Okay, everybody, let's do a little recap of the lesson. So we talked today about moving graphs, okay? So before we talk about moving graphs, let's talk about our most basic linear function. Our most basic linear function is just the y equals x equation. It has some invisible numbers. We know it's 1 over 1. We can put the invisible numbers if we need to. You know, it's a 1 over 1x plus 0. But it's this pink one right here. That's our y equals x. Start at 0, up 1 over 1. So we call that our parent function. What we want to do with our parent function is we want to move it. We're either going to move it up or down. So in the first example, it says we want to subtract 5. We're going to move it down. So that's going to affect the y values. Because we move it down, that's going to affect the y values of the graph. You can see moving it down, down, down. So if I subtracted 5 from all of the y values of the original function, then it becomes these values here. So when I graph it pulls the whole graph down 5 values. So we translate it. Translation means to move it down 5. So the new equation would be a y equals x minus 5, okay? So then what do we know about the two graphs? The original y equals x and y equals x minus 5, we know they're parallel. And one of the reasons we know they're parallel is because they have the same slope. We talked about that quite a bit in class. That if two lines are parallel, they have to have the same slope, okay? 1 over 1 is the slope, and 1 over 1 is slope, same slope, so they're parallel, okay? So then we did the same thing, and this time we moved it up 5. So we took our graph, and to take our parent function y equals x and move it up 5, every single point of 5, we just added 5 to all of the y values. So here are my x values, and -2, then my y value would be a positive 3. At -1, my y value would be 4. At 0, I'd add 5. My y value would be 5. At 1, I add 5. I'd have 6. At 2, I'd add 5. I'd have 7. If I graph these points, I get this line right here. An easy way to do that is just say the equation is y equals x plus 5, because I'm just adding 5. Take my parent function, and I'm just adding 5 to it. That's all I'm doing. Super easy, okay? And they are parallel. So then we looked at the next page. It doesn't have to be the parent function. It could be any function. So we started with this function, j of x. It's just a name of it, j of x. 2x minus 1 is this line here. And then we said, well, let's just take the whole thing up 4. So we took it up 4, up 4, up 4. But that's just as easy as taking my original function, which is here, and I added 4, which makes, if I put those two numbers together, I get a positive 3, 2x plus 3, which is the new equation. And then if I wanted to move it down 4, I took my original equation right here, and I subtracted 4 from it. So if I subtract 4 from it, -1, -4 makes -5, and there it is. So we just moved the graph either up 4 or down 4, and the easiest way to do it is just subtract or add 4 from the equation. Super easy, okay? And again, what do they have all in common? All of these three have the same slope. So since they all have the same slope, we know they are parallel, okay? And that's what I had for today. I gave them a worksheet for homework on review. I think it was the pre-test for tomorrow's quiz. That's all I have.